A lot of the problems in college algebra can be simplified if you know what the graph of a function looks like just by looking at the equation of the function. Therefore, there are several graphs of functions that we call parent functions that you need to memorize what the shape of their graph looks like. The first parent function we have f of x equals k, where k is any constant, and that is the graph of a horizontal line that goes through the y-coordinate of the point k. The next function that we have is f of x equals x, and we call it the identity function. And that is the graph that has a slope of 1 that goes through the origin. So it's a 45-degree angle that goes through the origin, and that is called the identity function. Next graph function that we have is f of x equals x squared. We call it the squaring function. And it looks like this. It's a concave up parabola, 0 to 1, 1 to 4, negative 1, and up to 4. That's the squaring function. Graph after that, we have f of x equals the square root of x. And we call that the square root function. And the shape of that graph looks like this. Starts out at 0. Square root of 1 is 1. The square root of 4 is 2. Continues forever to the right. Next graph I want to talk about is x cubed. We call it the cubing function. So f of x equals x cubed. It's called the cubing function. Its graph looks like this. 1 cubed is 1, 2 cubed is 8, negative 1 cubed is negative 1, negative 2 cubed is negative 8. This is the memorized shape of the graph of the cubing function. Then I have f of x equals the cube root of x. This is called the cube root function. Cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. And that is this graph. The next graph that I want to talk about is f of x equals 1 over x. We call this the reciprocal function. And it is a hyperbola in quadrants 1 and quadrants 3 with the axes as asymptotes. So if I put a 1 in here, I get 1, and then it approaches the x-axis and the y-axis. If I put a negative 1 in for x, I get negative 1, and it approaches the x-axis and the y-axis. The 8th function that we have is f of x equals the absolute value of x. And it looks like the identity function on the right-hand side of the graph. And then if an absolute value just changes these negative numbers to a positive number, so it flips the left-hand side up above the x-axis. And that is the absolute values function graph. Note that this forms a right angle because if this is 45 degrees and this is 45 degrees, what remains in here has to be 90 degrees. Please note that in your book, they do not have the cube root of x listed as a parent function, but for the purposes of my class, the cube root of x needs to be a memorized graph. Your book also has one other function that they call the step function, which I'll get to after we talk about the domain and range of these 8 functions. The constant function, its domain is all real numbers. Negative infinity to infinity. The range of a constant function is just whatever the y value happens to be for that constant, and because the y value is a single point, we will put it into set braces. The identity function is a polynomial function, so its domain is all real numbers. And its range is all real numbers because it goes down to negative infinity and up to infinity. The squaring function is a polynomial function, so we know its domain is all real numbers, negative infinity to infinity. And its range starts at 0 and goes up to infinity, so it's square bracket 0, comma, infinity. The square root function is not a polynomial function. Its first x value is 0, so the domain starts at 0 and goes all the way up to positive infinity. Similarly, range starts at 0 and goes up to positive infinity. Absolute value of x function, I can put any real number in for x, so its domain is all real numbers. And its range, the first value I get is 0, because any negative number is going to turn back into its positive one. So my domain, my range, starts at 0 and goes all the way up to positive infinity. For the cubing function, it's a polynomial function, so the domain is all real numbers. The range for the cubing function, it starts down at negative infinity and goes all the way up to positive infinity. So again, it's all real numbers. For the cube root function, it is not a polynomial function, but its x values, I can put any number, real number I want in for x. So its domain is, again, all real numbers. And its range is, okay, this continues down forever. I can take the cube root of any negative number I want to, and I can take the cube root of any positive number I want to, so its range is all real numbers, negative infinity to infinity. The reciprocal function is not a polynomial function. What I see is I can put any negative value for x in here I want. I can put any positive value in there for x I want, but I cannot put a 0 in for x. So the domain is every negative number, so negative infinity to 0, non-inclusive. Every positive number, 0 to infinity, not inclusive, and I union those. My range, my y values go from negative infinity up to but not including 0, and from 0 up to a positive infinity. So my range would be from negative infinity to 0, unioned with 0 to positive infinity.